Welcome to 4 or 5 Examples, Part 2. If you remember, we were looking last time at the change in period, and I left you with this problem to look at or try, and now we'll kind of go over this one. And I'm going to use cosine x first and then cosine 3x. And so in this one, I'm going to kind of look at things a little bit first. So I'm going to write in some color coding. So y equals cosine x is going to be our original one, and I'm going to do that in black. Before I scale my axis, though, I want to think now about y equals cosine 3x, and that means b is 3, b is equal to 3, and so our period for cosine is going to be 2 pi over b, so it's going to be 2 pi over 3. And so then really before I move on, I want to make the x-axis easy to divided into 4 parts for my increments. And so kind of to think about that, I'm going to take my period, which I know, in a basic cosine function like the black one's going to be, it will go from 0 to 2 pi. And I'm going to take this period, 2 pi over 3, and I'm going to divide that by 4. So that's going to be 2 pi over 3 times, and then 4 is like 4 over 1, so 1/4. And I'm going to get, I'll get 2 pi over 12, 2 pi over 12, which is pi over 6. Sometimes you might even use twelfths if when you get that 2 pi over 12. It's up to you as you go. And so what I'm going to do is I'm going to use that as 1/6 as I go. So I have a little luxury here, and if I think of it, I'll try to maybe change the axis on the ones for the handout after I've recorded this. But since I'm going to go out sixths, if I could, I might move this axis over a little bit, and then 1, 2, 3, 4, 5, 6. There will be pi right there, and 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's 2 pi there as well. So remember, this one's going to be happening 3 times as fast, but I am going to have that cosine there as well. And my amplitude doesn't change, so I'll go 1 there and -1 there, and 1, 2, 3, 4, 5, 6. There will be negative pi. This is going to be pi, and this is going to be 2 pi. So you'll see, that when I put in this original function, and I'm going to use black for this, remember cosine starts at the top and then goes to the middle, bottom, middle, top. And for this regular cosine one, we start at 0 and we go to 2 pi. And so that's why I wanted to make sure to have 0 to 2 pi on there. This other one's going 3 times as fast. So in that same space from 0 to 2 pi, I should get 3 periods of this other one. And hopefully by dividing that into sixths, I will be able to see where that is. So first I'm going to use my black and graph the cosine. So I'll be at the top, halfway, or, my 4 cubby holes, maybe I should kind of mark those off. So it's like pi over 2, pi, 3 pi over 2, and then 2 pi. So then I'm at the top, then the middle, then the bottom, then the middle, and then the top. So there's my 1 period of the cosine function. That's the plain cosine. Now I'm going to go to red and I'm going to say, okay, the period is 2 pi over 3, but remember 2 pi over 3, because I made it into 6. When I multiply these by 2 over 2, I get 4 pi over 6. So that means and I'll write this in red, but then I'm going to get rid of it. So these are 6. 1, 2, 3, 4. In that space, I'm going to get a period. Then 1, 2, 3, 4. In that space, I'm going to get another period. And then 1, 2, 3, 4. In that space, I'm going to get another period. So that's how I'm going to end up with my 3 periods. And so it's just going to be every little box is going to be one of my cubby holes. So this one starts at the top, middle, bottom, middle, top. So there's one period of this cosine 3x. So there's one, so it's 3 times as fast, so it takes 1/3 as long, so to speak. Then middle, or excuse me, gosh, I didn't go to the middle. My apologies. Middle, bottom, middle, top, middle, bottom, middle, top. And somehow I have a little stray red mark, but that's okay. I do expect you to have the key terms on there and or key points, key points on there. And then if you don't always have the graph hit those, it's not a huge deal to me as long as the X or the key point is there as you go. Okay, now there's mine. I had used a little close axis there. I might get rid of that one. Then translations of sine and cosine curves. That's our kind of next little part that we're going to do. And so pause this if you want to write that little subheading. And, you know, I always have in my mind things that are going to help me to kind of figure things out as we go. Now, you can't just say it's going to go left or right C units because really there's this B here dynamic as well. And so remember that the sine of X goes from 0 to 2 pi. And so this bx minus c is going to give us a horizontal translation or shift, that kind of left or right. And so remember that the sine of bx has a period of 2 pi over b as we go. And so think about, you know, even finding zeros and things like that. Now our start of our cycle is going to be, so the cycle starts when bx minus c is equal to 0, because that's when sine or cosine functions start. And the cycle ends when bx minus c equals 2 pi, because that's where the cycle ends there. And so I'm going to slide that down. So that means it's going to start, if we add c and divide by b, that means x equals c over b is going to be the start of one cycle. And then if we kind of solve this one, we're going to add c to both sides. And I'm going to write that c in front. So that's going to be bx equals c plus 2 pi. And then we're going to divide by b on both sides. And I'm going to separate those two fractions. So I'm going to say x is equal to c over b plus 2 pi over b. And kind of think about the fact that, oh my goodness, look at that. 2 pi over b is the period of this sine function. So we can really say that that's going to be x equals c over b plus the period. So kind of think about that. If the cycle can start at C over B, and then if we add the period for this new situation, that will be where that cycle ends, so that we get one period. And that is called the phase shift. And I think maybe I have to go a little slide or two ahead. But the left end point is this C over B, and the right endpoint is this C over B plus 2 pi over B, which is the period. This C over B is called the phase shift. And it'll say that, oh no, it doesn't really say that on the next slide. I was peeking ahead for myself. So you do want to write down that that is the phase shift as we go. And so now our next little box of information says graphs of sine and cosine functions. The graph of y equals a sine parentheses bx minus c and y equals a cosine parentheses bx minus c have the following characteristics. Assume that b is greater than 0, and the amplitude is the absolute value of a. The period is 2 pi over b, and then we've kind of had those already, but the left and right endpoints can be determined by solving the equation bx minus c equals 0 and bx minus c equals 2 pi. And we'll be doing that as we go through these problems. So let's look at this next problem, and several things are going to be happening here. And let's just kind of analyze the graph, and analyze it first, and then we'll graph it. So this is y equals a sine bx minus c. And so just kind of thinking about what these things are, a is 1/2, b is actually 1 in this case, and c, notice it is minus c, so c is pi over 2. So that's just kind of figuring out what A, B, and C are. So now let's think about our things like amplitude, period, and beginning and ending. So our amplitude is equal to A, which is equal to 1/2. So it's only going to go up 1/2 and down 1/2. And then our period is 2 pi over B. So that's, in this case, 2 pi over 1, which is 2 pi. So that makes that part a little easier to handle. And then we want to do this beginning and ending. So the beginning of a cycle is when bx minus c equals 0. So that's x minus pi over 2 equals 0. So that's x equals negative or positive pi over 2. And the end of the cycle is when this bx minus c equals 2 pi. And so that is going to be x minus pi over 2 equals 2 pi. So I'm going to add pi over 2. So I'm going to write x equals, and then I'm going to get a common denominator there. Maybe I'll just write it first, pi over, or 2 pi plus pi over 2. So I'll get a common denominator. This is over 1, so I'll multiply by 2 over 2. So x equals 4 pi over 2 plus pi over 2. And so x equals 5 pi over 2. And so my cycle is going to go from pi over 2 to 5 pi over 2. And think about 5 pi over 2 minus pi over 2 is 4 pi over 2. So it's still 2 pi for that one period. But I like to figure that out so that I can kind of see where things are going to happen as we go. And so these are pi over 2 as we go. And so let's just use the increments, I think, of pi over 2, because our period is still 2 pi. 2 pi divided by 4 is pi over 2. So I think we'll just use those as our cubbyhole boxes. So um, let's go pi over 2, 1 pi, pi over 2, 2 pi over 2, 3 pi, 3.5, and then 4 pi. I'll just go out to 4 pi there. And it's only going to go up a half, and so I'm going to make 2 boxes be a half. And just so that it's easier for me to draw it in as we go. And we'll just stay on this positive, or the positive axis as we go, where we won't put anything in the negative area. Okay, so things we have to think about. Maximum and minimum are a half and negative a half. Um, Period is 2 pi. So it should be in 2 pi, but then it's shifting pi over 2. So the start of our period is at pi over 2, which is right there. And it is sine, so it starts at the middle. And then, so we have to think about getting to 2 pi is right there. So our cubbyhole is 1, 2, 3, 4, and that would be 5 pi over 2, which is 2.5 pi. And so I'm at the middle, then the top, then the middle, then the bottom, then the middle. And let's just kind of draw that in. And notice, I'm going to pick it up a second, and notice that if it were just 1/2 sine x, it would be right there. But this has shifted it over to the right pi over 2, and that's what we would have expected as we go. And maybe we'll just put that one period on there. We've got more on the graph, more graph space, but let's just kind of put that on there and kind of be done with this one. So now, why don't you pause this and try this next one, and then we'll kind of see how it is. I'm just going to move along, but if you want to feel confident and want to try that, then go ahead and see what happens there for yourself. Oh, I just realized that is that same problem that we just did. And so let's move on to this one. And this is the one that I thought I was showing you for you to try if you would like. And then we'll go over it. So what I'm going to do is kind of go through it little piece by piece. Okay, let's analyze this first and kind of see what we are thinking. Notice it's -3. So if it's negative, that means it's going to reflect across the x-axis. I want to remember that. Sometimes I forget that. And then A is equal to 3. So the amplitude is 3. That means it's going to go up from the middle, up 3 and down 3. And then B is 2 pi. So that's a little unusual. It's not just an integer, it has pi in it. So our period is going to be 2 pi divided by 2 pi, which is 1. So that's kind of unique. And then think about the fact that we want to divide that period into 4 cubby holes. So I think each marking on the axis is only going to be 1/4. So 1/4, 1/4, 1/4, 1/4 will give me 1. Then also we want to think about where we're going to start. And so our start is where all that stuff in parentheses, 2 pi x plus 4 pi is equal to 0. So I subtract 4 pi and I divide by 2 pi. And I get -2. So even though I'm using 4s, I'm going to start my increments at -2. And then my end of the period, one period, is going to be when that stuff in parentheses is equal to 2 pi. So I subtract 4 pi and I divide by 2 pi and I get -1. So I'm going to use a lot of cubby holes there and my amplitude is 3. Hopefully I don't mess up anything, but let's see what happens. And my axis is a little bit off of there. And it's, if you notice, I'm going from -2 to -1. So my period is going to be kind of way over here. So I'm going to use 8 little boxes and I am going to fix my axis just a little bit. Oops. There. And so when I do this, I'm going to go 1, 2, 3, 4 back to be -1. 1, 2, 3, 4 back to be -2. And if you remember, my period goes from -2 to -1. And I'll just go forward 1, 2, 3, 4 to maybe +1. There's 0. I know my maximum and minimum are going to be 3 and -3. So I'll still go 2 boxes. 1, 2, 3. So it's going to be kind of stretched up there. 1, 2, 3, -1, -2, -3. And then I have to keep in mind that I'm reflecting across the axis. So let me just kind of think this through a moment. I'm going to start my period at -2. I'm going to end it at -1. 1, 2, 3, 4. I've got my cubby holes. I'm going to reflect it across the x-axis, so it's cosine. Cosine starts at the top, middle, bottom, middle, top. But since I'm reflecting it, I'm going to start at the bottom. Here's my, oops, my period is going to be right here. I'm going to start at the bottom, middle, top, middle, bottom. So it's going to look like that. And that's all going to happen in between there and there. And so the bottom is where I'm going to start right there, middle, top, middle, bottom. And so let me get rid of all that yellow. My planning yellow. There we go. And let's see what happens. I might just draw this a little thicker than sometimes, and that just might help me find things a little better. So -2 is the start of my period, and then I'm going to be at -3, 0, and then +3, and then 0, and then -3. Maybe this thicker marker was a bad idea, so I'm going to go back to thinner. So there's one period, and my amplitude is good. I've got it shifting, and I've got my period is 1, and so it's all good. Now I'm just going to make some more points and go all the way out to +1. So I'm at the bottom, middle, top, middle, bottom, middle, top, middle, bottom. And so not my best graph ever, but it is always a little harder not being on the smartboard as such. So there is our graph, and that concludes number 5, and we will look at the vertical translations in the next part. So this concludes part 2.